All right. So, 2 days ago, we talked about how to solve logarithmic equations with common bases. Not logarithmic, exponential equations with common bases. So, remember, that was when we had something like this. So, let's say we had 2 raised to the x plus 8 power is equal to 16. All right. Now, remember, the method of common bases is when you would use your power chart and look to see what column both 2 and 16 would fall under. So in other words, a base raised to the same base raised to a specific power would give you both of those numbers. All right. So what would be the common base between 2 and 16? Well, technically 4 would work, but I was shooting for 2. Yeah. 4 would technically work, but we'd have to involve fractions. So 2 would be our base. So that means I'm going to convert 2 raised to the x plus 8 because it already has a base of 2. And then I'm going to convert 16 to 2 to some power. 2 to what power gives you 16? 4. So 2 to the 4th gives you 16. This starting to ring some bells, guys? All right. Now remember, once we got the common base, what do we have to do? Right, the bases cancel out. We bring down what's in the exponent. So this would be x plus 8 is equal to 4. Subtract the 8. X is equal to negative 4. All right. Now, the method of common bases cannot be used for every exponential. It's actually pretty rare that you get common bases. All right. It's very limited. But this method that we're going to learn today, which is through logarithms, you can solve any exponential equation with it. All right. So that's what we're going to do today. So again, the method of common bases, which is what we just did up there, it's really limited. But we can do any exponential equation if we use logs. Now, before we get into how to do it, we need to talk about a law of logarithms that will help us when we start solving. All right. And that logarithm law is called the power law. So just like how we used the power rule when we did same bases, if we had to multiply exponents together, not quite the same thing here. It's actually a lot easier. So all it states is that if you have a log and then something raised to some power within the parentheses of the log, if we don't want that exponent, the only thing we got to do to get rid of that exponent is we just take it and bring it in front of the log. So it's exactly the same thing as x times the log of b of a. Now, why is that important? Well, when we solve using logarithms, we are going to have to get the variable out of the exponent. That's how we do it. We bring it out of the log. And that doesn't really make much sense now, but it'll make sense in just a second when we start solving. All right. So let's look at exercise 1. We're going to solve first for the x power is equal to 8. Now, we're going to do it in 2 different ways. We're going to do the method of common bases first, because that does have a common base. And then I'm going to show you how to do it with the log approach. Either way, we should get the same answer. So, whereas the method of common bases, you can only use it for specific exponentials, the method of logs, you can use for any exponential. All right? So, first off, let's do common bases. So, between 4 and 8, if I were looking at my power chart, what column, so what base, would have both 4 and 8 under it? So that base raised to whatever power would give us 4 and 8 eventually. 2, good. So I'm going to change this so that it's with a base of 2. So I'm going to write 2 and then parentheses something to the x power, because remember we got to bring down whatever's already in the variable. Not the variable, whatever's already in the exponent. And then write another 2, and we're going to raise to some power. 4 is equal to 2 to the what power? Or in other words, 2 to the what power gives you 4? 2. So 2 squared gives us 4. 2 to what power gives us 8? 3. Now, before we can cancel out our bases, we got one more thing we have to do. What is that thing? Right, we got to multiply the two exponents, so we got to do the power rule. So that just means we multiply the 2 and the x together, so this would be 2 to the 2x power is equal to 2 to the cube. Now we can drop our bases. So I get 2x is equal to 3, and then I just got to divide by 2 to solve for x. So x is equal to 3/2. Now, that was the method of common bases, short, sweet, to the point. The method of logs is a little bit more lengthy, all right? But if this was on your test, I would expect you to do common bases, obviously. So if it has a common base, use common bases. Yeah, I'll let you use it on your test. So I'll probably do the same thing like the last one and let you guys make the one-pager, but then I'll also let you use your power chart. All right?
So the power chart doesn't have to be on which of these?
No, I'll let you guys actually use your power chart. That's the only resource outside your one-pager I'll let you use. Okay? So let's look at the logarithm approach. So we're solving the same problem. So I'm going to do 4 to the x is equal to 8. Now, with logarithms, because logarithms and exponentials have a very close connection, they're inverses of each other. In other words, they undo each other. We want to undo this exponential. So it's like if we want to undo multiplication or undo division. How do we do that? We take the log of 4 to the x power. And remember, whenever we do to one side, we got to do to the other. So since this base is by itself, we can go ahead and do the log of both. So in other words, since when I say the word take the log, I mean literally log and then whatever it's next to it, that goes in the parentheses for the log. So this would then be log to the 4 to the x power is equal to log to the 8. Now, let me make something clear. First off, I'm using the common log. So review from yesterday. Common log is what? Right, it's a log with a base of 10. So really with any log, with the logarithm approach, you can use any type of log as long as it's consistent. So you could have used a log base 2, a log base 3. When I was growing up, I learned it using natural logs, so technically log base E. But for general purposes, just use the common log. Right? It's easy, no complications to it. All right. Now, something else I need to make clear. Log of 8 is a number. All right. And we're going to treat it as such. So it's kind of similar to, like, say, if we said the square root of 2. All right. It's a number, but it's a gross number. So if I do log, actually hitting the log key of 8, I get a number. It's just terrible looking. All right. So just remember that you see log and then just some number and there's no variable with it, it's a number. All right. And the reason I say that is because that will come into play with our next step. So just remember this is a number. Now, our next step is we need to take the x out of the exponent. And that's where that log law that we just went over comes in handy. So all we got to do is take the exponent and bring it in front of the log. So this is now x log of 4 is equal to log of 8. Now, once we're here, remember, log of 8 is a number. Log of 4 is also a number. So in reality, x to the log 4, we can treat it like it's some normal number that we're used to seeing. with an x next to it. So what operation is technically being done there? They're multiplying. So how would I get rid? So how would I get the x by itself here? This is being multiplied with this, and this is a number. You just divide it to both sides. So you would treat it like it was like 2 to the x. You would divide by 2 both sides. You would divide by log of 4 to both sides. All right. So I'm going to divide both sides by log of 4. Because remember, log of 4 is just a number. It's an ugly number, but it's a number nonetheless. Even ugly numbers are still numbers. So my answer is this. Now, this would be my exact answer. All right. Typically, whenever we do this, I would have you guys put in your calculator to get an answer. Now, this answer will end up being nice because since it has a common base originally, it will end up being a nice answer. But typically, if this was an equation where they didn't have common bases, it would not be a pretty answer and you'd have to round. All right. So we're going to put all of this into our calculator to get an answer. So, and be very careful with how you put it in. Make sure you're closing your parentheses. So I'm going to type in log, using the log key, of 8, close the parenthesis, divided by log of 4, close the parenthesis. Make sure you close that parenthesis on the log of 8. If you do not, it will do the divide by log of 4 within the log of 8. All right? So since I closed the parentheses, it's saying that those are two separate numbers and I'm dividing. Hit enter, I get 1.5. Now I want to see if that's the same as what I got from my other one, which is 3/2. So I can hit math and then enter twice, converts 1.5 to a fraction, and it is in fact 3/2. So x will be equal to 3/2. So even though we did two different methods, it's exactly the same. So when it comes to logarithms, the method of logs for solving exponentials, it will work. It will work with any exponential function, regardless if it's common base or not. Common bases only works if there is a common base. All right. So if there's obviously not a common base, don't even try to attempt it. All right. You have to use the method of logs. Any questions? All right, so let's do one where there's obviously no common base. So just to note is that the beauty with the logarithm law that we just went over is that it removes the variable from the exponent. All right, it literally undoes that exponential. And again, we use common log as our log that we like to use. Now, if this was me, my go-to is natural log, so ln. It doesn't matter what log you use as long as you keep it consistent. In this class, I just recommend the common log or the natural log. It doesn't matter which one you use as long as you keep it consistent. Okay? But we're going to majorly use common log here. So let's do exercise 2, letter A. Now, if I look at this, so 5 to the x power is equal to 18. Is there any way that 5 and 18 have a common base? No, it's impossible. So we have to use the log method here. So since the 5 to the x power is already by itself, I'm going to go ahead and take the log of both sides. So I'm going to have log of 5 to the x is equal to log of 18. So once I'm here, what's my next step? Right, we got to bring out the x. So the x is coming out. So this is x log of 5 is equal to the log of 18. And then what would my last step be? Right, divide both sides by the log of 5. So my exact answer would be x is equal to the log of 18 over the log of 5. Now, this one is one of those where it will not give you a pretty answer, so we're going to put in our calculator and we're going to round it to 2 decimal places. So if I put in my calculator, I have log of 18 divided by log of 5. So if I round that to 2 decimal places, what is it? 1.80 or just 1.8. All right. So this will be approximately, make sure you're using the approximate symbol, 1.8. Come on, my sleepy babies, wake up. I know it's Friday, but we're almost done. Well, not with the notes, but we're almost there to the weekend. It's not actually that long. The problems themselves are just step heavy. So, just to note, this right here will be your exact answer. This right here is going to be your approximate answer. All right. So on the test, it's mainly going to ask you for an approximate answer. Now, if you can get to here, that's awesome. Okay. Which, I mean, in reality, all you have to do is put that in your calculator at the end. So why not just go the extra step? Now, I know this method looks like it is terrible, and it kind of is. All right. It can get tricky. There can be a lot of things going with it, and a lot of people get confused with just the word log being put in there. So if this was the EOC and they gave you an equation that looked like this, and you forgot how to solve it by hand, what would you do? Which calculator? Desmos. How would I put that in Desmos? So we talked about this when we were solving absolute value equations. It's the same method. How'd you do it? So you can take both parts of the equation. So the left side equal sign, the right side equal sign. Put it separately into Desmos after you set equal to y, and then you're looking for the what? The intercept. No. You use the original equation. So, just for an example, I'm just going to do it real quick. You don't need to do it. I'm just going to put it in. So I'm going to type in y is equal to 5 raised to the x power, and then y is equal to 18. And then I'm going to zoom out till I see where it crosses. So it crosses right here. And remember, you always use the x value of your point. So is it true that if I rounded the x value of that point, is that not the exact same answer that I got? That's true. So guys, if you have any doubt in your mind, I still want you guys to learn how to do it by hand. But if this was the test and you just completely forgot how to do it, try your best. But if all else fails, check your answer in Desmos. All right? Using your tools appropriately is still a huge part of math. And that's why I teach you the Desmos way as well, because it actually helps you with solving equations. And to be honest, it's not like you're just putting it. It's not like you're putting it into Chat GPT and it just gives you the answer. All right, there's a little more to it. You actually have to understand that a point of intersection and the x value of that point is your answer. You got to understand that you put both sides of the equal signs in different parts of Desmos. Okay, so this was either the test or the EOC. By all means, use Desmos to your advantage. All right, but I still want you to at least attempt the log method. All right, because it's honestly not bad. It just gets lengthy. All right. So let's try another one. So let's try letter B. So same process as last time because the base is already by itself. Walk me through. What's my first step? Take the log of both sides. So I'm going to take the log of both sides. This will be log of 4 to the x is equal to log of 100. What's my next step? Someone who has not talked yet. Right, bring the x out. So I got to bring the x out. So do not divide until you bring your exponent out, okay? Now what do I do? Divide by what? Log of 4. So that goes away. I get x is equal to log of 100 over log of 4. All right, now someone put that in your calculator. Tell me what you get round to 2 decimal places. So if you put in your calculator, what do you get approximately? Be what? So 0.346. So what's that rounded to 2 decimal places? Yeah, it should be 3.32. So it's approximately 3.32. Now, when it comes to solving exponentials, this was like the very, very basic, very easy ones. All right. So let's look at one that's a little bit more complicated. So there's a little extra to it, but it's not bad, honestly. It just has like one extra step at the end. All right. So let's look at exercise 3, part A. I want to make sure we get to this lesson today, so we're not going to do a free example. I mean, if you want to do it on your own for extra practice, go for it. But fair enough. All right. So with letter A, all right, we're adding a 3 in our exponent. That's really not going to change anything with the process that we've already learned, except for it's going to add one extra step at the end. All right. So the base is already by itself. There's nothing being multiplied or added to it. So we can go ahead and take the log of both sides. So I'm going to take the log of both. So this will be log of 6 to the x plus 3 power is equal to the log of 50. Now, our next step is to bring out our exponent. Now, get in the habit. If your exponent is anything besides x, get in the habit of putting parentheses around your exponents. Because, like we talked about with the Loggy Froggy example this morning, if it's in parentheses, they stay together. They're a package deal. They got to go with each other. All right? So wherever they go, so wherever the x goes, the plus 3 follows. Okay? So when I bring out my exponent, I'm bringing out the entirety of x plus 3. So this will be x plus 3 times the log of 6 is equal to the log of 50. Now, what do you think I would do next? So think back to how you started that problem that we did this morning. Nope. You got to do something first. can't distribute the log of 6. That's too much work. Divide by log of 6. So since we're multiplying this entire expression to the log of 6, we got to divide first. So again, same process as what we were originally doing. I said there's just going to be one extra step at the end. So this will be log of 6, divide by log of 6. So that goes away. And I get x plus 3, and I can drop the parentheses since the log of 6 is gone, is equal to log of 50 over log of 6. Now, I'm not going to put this in my calculator yet because I got one more step. Because the x is not by itself yet. What's the last thing that I got to do? Subtract 3. Now, when we subtract 3, we're subtracting 3 to that entire expression. All right? So we would just write this as log of 50 over log of 6. And I would put all of that expression in parentheses and then do a minus 3 on the outside. I'm about to show you. So, my recommendation is do this in parts when you put in your calculator. So do the log of 50 divided by the log of 6 first, get that answer, and then just immediately hit minus 3 afterwards to get the total answer. So, if I did this in my calculator, stop. Okay, there it goes. So I'm going to type in the log of 50 divided by the log of 6. So once I get this answer, I'm just going to immediately hit minus 3. Because remember, if you do an operation after you get an answer, it automatically inputs your previous answer. All right? And I'm going to hit enter. So if I round to 2 decimal places, what is that? Negative 0.82. Good. So x would be approximately negative 0.82. So guys, essentially it's the same process that we've already learned. The only difference is that after we divide our log over, we still got a couple more steps to do. So after that point, it's like we're solving like a 1-step or 2-step equation. All right. So what I want you guys to do, I want you to try letter B on your own. And just so you know, the exponent is x over 2 minus 5. So instead of 1 step at the end after we divide the log over, you're going to have 2. So
So times two. Yep. That's right.
Oh, yeah. It's only when you have a log and there's a little number. Math, since it's going down to these numbers. Guys, 1 more minute. We're gonna go. Also, once we go through this, we'll go on the break, and then we'll do the last little bit. Like, after the break. Okay. Okay, so we're present. God. Oh. Don't.
All right. Shh, shh, shh. All right. Let's go with Frederick. What's my first step? Right. Take the log of both sides. So this would be log of 1.03 raised to the x over 2 minus 5 power, and it's equal to log of 2. Let's go with Jackson. What would be my next step? Right, bring down our exponents. So the x over 2 minus 5, and I'm going to leave that in parentheses just so I know it's being multiplied to the log of 1.03. All right, let's go with Leslie. What's my next step? Divide by what? Right, divide by the log of 1.03. I crossed out the wrong one. So that goes away. I get x over 2 minus 5 is equal to the log of 2 over the log of 1.03. All right, Alexa, or Alexis, sorry. I have Alexa in my other class. So Alexis, what's the next step? Right, we would add 5 to both sides because the x is not quite by itself yet. So I'll get x over 2 is equal to log of 2 over log of 1.03. I'll put parentheses around that so I know that I add 5 to all of it. And then Layla, what's my last step? So I'm here. So what's my last step?
You have to put it you have to put that on that side and change your parentheses so you can multiply it by 2.
Right. So we're going to multiply by 2 to both sides. And we got to multiply 2 to all of this. So this would be x is equal to, because I'll cancel, log of 2 over log of 1.03 plus 5 and times 2 entirely. So this would be our ugly exact answer. So Dylan L, what is my approximate answer to 2 decimal places? Right, it'll be approximately 56.90 or just 56.9. Now again, since that one was so messy, you could have also plugged that into Desmos, found the point of intersection to check it. All right, so when in doubt, check it in Desmos. Okay. All right, you're going to take your 5-minute break. I want you back in this room by 12:30. All right, guys, let's get back to the grind. So, last thing we're going to talk about is how to use this method to solve exponential equations that we get from word problems. So, recall 2.2, all right? When we did all those different types of word problems, and basically all you had to do was plug it into your, set it up, plug it into your calculator, get an answer. Well, now, since we have the tools to solve it, we're going to actually be solving from x instead of finding the y value. All right. So we're just going to do a pretty straightforward one. So a biologist is modeling the population of bats on a tropical island. When he first starts observing, there are 104 bats. The biologist believes that the population is growing at a rate of 3% per year. So, would this be an exponential growth or exponential decay problem? Definitely growth. So, remember, exponential growth is the formula A is equal to P times 1 plus R raised to the T power, where A is your new value, P is your principal or initial value, R is your rate, and remember you write that as a decimal in the formula, and T is your time, typically in years. Say it one more time.
Oh, it's
Yeah, it's a 1. It's a 1. You're good. If just a note, if I ever write L's besides next to a log, I usually do cursive. So now it says for the number of bats B of t, we're going to write a function in terms of the number of years t. So B of t is my A value. So my P or my initial value would be what? What I start with? 104. Oh, crap. So I start with 104. Then I do 1 plus. What is my rate of growth? Say one more time. 3%. What's that as a decimal? 0.03. And then it's just going to be raised to the t power. Now, we're going to clean up a little bit within the parentheses, just add those two together. So we get B of t is equal to 104 times 1.03 raised to the t. So this would be the formula that we use to solve problems. This will be what we plug in any x or y values that we get. All right. You guys should be fairly comfortable with coming up with these by now. Okay. Good Lord, I definitely drilled you on it the last couple of days. All right, so now we're going to use that function to find B. So it says using your equation in part A, algebraically determine the number of years it will take for the population to reach 200. So 200, is that going to be plugged in for T or B of T? B of T, good. Because remember, B of T is your population, whereas T is your time. Well, we're trying to find our time. So I'm going to plug 200 into my formula. So this would be 200 is equal to 104 times 1.03 raised to the t power. And then from here, we're just going to do our logarithm method. Now, remember what I said about whenever you solve logarithms. Remember, the base of the exponential has to be by itself on one side of the equal sign. So that means nothing's being divided to it, nothing's being added to it, nothing's being multiplied to it, nothing's being subtracted to it. Is that true here? So it doesn't matter. So is that true here? Is the base by itself? Nothing's being multiplied, added, divided, or subtracted to it. It's not true. What's that going on? It's being multiplied by what? 104. So We gotta get rid of this 104 first before we can take the logs of both sides. How do I get rid of the 104? Divide by it. So I'm going to divide both sides by 104. So I'm just going to leave it as 200 over 104 because I don't want to mess something up in my simplification. So I'm just going to leave it as is because it's just going to go in your calculator anyway. And it's going to be equal to 1.03 raised to the t power. Now is my base by itself. Yes. So now I can take the log of both sides. I'm going to take the log of 200 over 104. And I'm going to take the log of 1.03 to the t power. So this would be log of 200 over 104 is equal to log of 1.03 t. What's my next step? Not yet. So I can't divide just yet. I have to do something first. Right, move the exponent out of the exponent. So I gotta move it to the front of the log. So this would be log of 200 over 104 is equal to t times the log of 1.03. Now what do I do? So how do I get the t by itself? Divide by the log of 1.03. That goes away. So t is equal to log of 200 over 104 all over the log of 1.03. Now that's our exact answer, but they want it in years and they want it rounded to the nearest year. So I'm going to put that in my calculator. So I'm going to type log of 200 divided by 104. So that's all within the first parentheses of the log. And then divide that by the log of 1.03. So I get like 22.1229 approximately. What is that rounded to the nearest year? 22. So they're saying that in approximately 22 years, the population of bats will reach 200. Now, again, if you completely forget how to do all that or you need to check yourself, put what we originally started with into Desmos. So if I do that, let me just do that really quickly just to show you. I have y is equal to 200. Oops. And then y is equal to 104 times 1.03 raised to the, let's call it the x power, because it doesn't really matter what variable's there. So I'm going to zoom out until I see it. So right here, and is that x value not exactly what we got? Yes. All right. So again, if you forgot how to do it, like say, because you have a weekend between now and the test, say you forgot how to do it by logs. Still attempt it, of course, but if all else fails and you're just on the struggle bus, Desmos. Okay? Because honestly, this is what I would expect you to do on the EOC. All right, any questions on any of this? All right, so your homework or classwork for this assignment for this, oh God. Your classwork for this lesson is the 2.4 Delta Math. It's already been assigned to you. It covers both common bases and log method. All right. So you guys got about 25 minutes until class ends. Use your time wisely. Yeah, it's homework if you don't finish it. Yeah.
How does it know? Because it has like the estimate